So today we're looking at independent events. Our goal here is to explain the difference between independent events and dependent events. So the next lesson after this will be dependent. But independent is where one event does not affect the outcome of another event. So the events are independent from one another. So when you're looking over here at the tiles and the spinner, when I go to draw a tile, let's say I pull out B, it doesn't affect if I take the spinner and I get an A. So we're going to take a look at this first problem and we're going to make a tree diagram out of it. So let's take a look at this problem. It says one letter tile is selected from this group and the spinner is spun. What is the probability that both will be a vowel? So we're looking at making a tree diagram. Here we have our tiles, G, B, E, and A, and then we have the spinner, which we have A, B, and C here, and you can see that we branch those off for each of these spins, A, B, and C, for a combination. And then we have here, this is our sample space. So the first thing we're going to be looking at is we want the probability that both will be a vowel. So looking here, we have an A and an E, and then we also have that A. So our outcomes as we go down where they're both vowels, oh, here's one. Let's keep going, an AA. So there are two. How many possible outcomes are there in the sample space altogether? So if we count through, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And remember, we could go back to that fundamental counting principle where we take 4 outcomes here times the 3 different sectors, which will give us that 12. So that's a fast way to get to that 12. So what is the probability both will be a vowel? And remember to simplify. Go ahead and write this as a fraction, a decimal, and a percent. So we know that we could get that combination 2 out of 12 times, which is going to be 1/6. So let's express that as a fraction. Remember, you want to take that fraction, 1 divided by 6. So here, we're going to get 0.16 repeating. And then as a percent, that's going to round on up to 17%. So the probability of getting 2 vowels is only 17%. So it's not likely to happen. Alright, so on the next page, we're looking at the probability of independent events. So the probability of 2 independent events can be found by multiplying the probability of the first event by the probability of that second event. So we're going to use the same problem here. We have our spinner and we have the tiles. So here again, we're looking for the probability both will be vowels, but instead we're going to use the quicker method, which is just multiplying the fractions with the probability. So remember, when you multiply the fractions, you're multiplying the numerator and the denominators together. So example, 1/2 times 1/4 is 1/8. So looking at the spinner, we're looking at the probability of spinning a vowel, which is 1 out of 3 sectors. Here, the probability of grabbing a tile that has a vowel is 2 out of the 4. Now remember, it's going to be quicker if we take that 2/4 and we make it 1/2. So we're going to take and multiply 1 times 1 is 1, 3 times 2 is 6, and we get the same answer without going through and making that entire tree diagram. So let's express the probability as a fraction, a decimal, and a percentage. which is going to be exactly the same as that first problem. All right, so let's take a look at a couple examples more on independent events. So we have these two spinners, spinner 1, spinner 2. Now they're identical. So really, if you roll a dice or spin a spinner, they're going to be independent events regardless of having 1 or 2. So here, the two spinners are spun below. What is the probability that both spinners will show a number greater than 6? So the first number we're looking at is 7 and then higher. So we have a 7, 8, and 9. Same thing here, 7, 8, and 9. So when we're looking at this, the probability is 3 out of 10. And then again on this second spinner, we have 10 sectors, and then there's 3 numbers that are greater than 7. So from here, we're not going to need to simplify anything because 3/10 is simplified. So 3 times 3 is 9. 10 times 10 is 100. So the probability is 9/100ths, or it's a 9% chance. It's very unlikely that you are going to spin a number that's over 6 on both spinners when they're spun. Looking at the next problem, it says the two spinners above are spun. What is the probability that one shows an even number and the second shows a 1, 2, or 3? So we're looking for an even number on one and a 1, 2, or 3 on the other spinner. So looking at the even numbers, we have 2, 4, 6, 8, and that 0. So half of them are even numbers. And let me do that in black. And we know we're going to multiply that by the second one that shows a 1, 2, or a 3. So here we only have 1, 2, and 3. So the probability on the next one is going to be 3 out of the 10. And then we're going to multiply. 1 times 3 is 3. 2 times 10 is 20. And then we can look at that probability simply as that fraction, 3/20ths. Or we can take and change that 3/20ths into a decimal. So remember, we're going to take 3 divided by 20, and you get 0.15. And from here, change that to a percent. So here, 15%, it's more likely than getting two spinners with a number greater than 6, but still not likely it's going to happen. All right, so last example here. A number cube is rolled and a letter is selected from the word America. Find each probability and show your work. Remember that P right here means probability of. All right, so we're looking for a number greater than 1 on the dice and a consonant. So greater than 1 is going to be 2, 3, 4, 5, and 6 on our dice. So the probability, we have 1, 2, 3, 4, 5 different opportunities to get a number we're looking for on the dice out of 6 sides on the dice. And a consonant. Consonants are not vowels. So when we're looking at consonants, we have the letter M, the letter R, and the letter C. Now we have 1, 2, 3, 4, 5, 6, 7 letters in the word America. And 3 of those are consonants. So we can multiply straight across, or we can simplify before we multiply. But let's just multiply straight across. 5 times 3 is 15. 6 times 7 is 42. So let's go ahead and simplify. Both 15 and 42 are divisible by 3. 3 goes into 15 5 times. 3 goes into 42 14 times. So we have a fraction of 5/14. So we can tell this is not likely, but let's go ahead and take 5 divided by 14, and it's going to come out to 0.357. So when we round this to a percentage, it's going to round to a whole number of 36%. So it's getting a little more likely than some of the other problems that we've seen. However, it's still not likely that this combination is going to occur. All right, so let's take a look at the last one. Here we're looking for a number less than 4. So let's come up with those numbers less than 4. It's going to be a 1, a 2, and a 3. And then our vowels. Well, we have A, E, I, and then another A. So let's write out the first probability. So when we're looking at 1, 2, and 3, that's 3 different numbers out of 6. So let's simplify this down to 1/2. So we're going to take 1/2, and we're going to multiply by the probability of A, E, I, and another A. So that's 4 out of the 7 letters in America. And then we can multiply straight across. 1 times 4 is 4. 2 times 7 is 14. And then we can simplify that down. Divide by 2. We get 2. 14 divided by 2 is 7. So you can still see here 2/7 is not likely to occur. And then if we take and we change that over to a decimal, I'm running out of room here, so 0.286 it rounds off to, which is going to give us a whole percentage of 29%. So it is not likely to happen. Thanks for watching. Come back real soon for more videos. Bye for now.